and it's a great pleasure to introduce Angie, the first place winner of the Latinx 2023. And Angie Vanessa Patinho Sepulveda made continuous contribution. Is it? Can I go on? Yeah. So Angie made continuous contribution to her educational community by being a part of the academic group Organización Juvenil de Líderes, established within the educational institution. Within this group, they organized academic events such as regional panels and national forums that addressed various topics of social and philosophical interest. At the university, she has been actively involved in new groups within the field of physical chemistry, notably contributing to the research group known as Grupo de Investigação em Fotocatálise e Estado Sólido. Here, she has dedicated her efforts to enhancing the academic landscape of physical chemistry with a strong emphasis on green chemistry applied in laboratory. Angie has accumulated significant experience in the field of quality analysis, particularly in water and food analysis. Over 3 semesters, she has served as a monitor, in the water and food analysis laboratory at the Universidade Tecnológica de Pereira. So Angie, thanks for accepting our invitation. Congrats for your first place winner. And you can show your beautiful work.
Thank you. Now, can you see my screen?
Yes, we can.
Okay, thank you. Okay, good afternoon, everyone. I am Angie Vanessa Patinho, and today I'm going to present millimeter scale physical chemistry and its impact on green chemistry in the laboratory environment. Well, this research project aims to enhance the didactic design of practical laboratory courses by implementing environmentally friendly ideas. I am currently an undergraduate student about to finish my degree in industrial chemistry at Technological University of Pereira in Colombia. There, together with the photocatalysis and solid-state research group, we created our team where, thanks to the physical chemistry teachers, Johnny Rodriguez, Héctor Fabio Cortés, Maribel Montoya, and Hubert Valencia, we are showing the positive results of carrying out this project in the School of Chemistry. Okay, this is our overview where I choose the physical chemistry practices for this work. Well, what did we achieve this project? A significant reduction in the cost and chemical waste that is normally generated in the practical laboratory subjects. For this, considering the programs of industrial chemistry and chemical technology of the School of Chemistry, initially it was necessary to make a review of the contents and methodologies of the courses in the area of physical chemistry. There, our focus was the respective laboratory, practical laboratory subjects. Now, considering the fundamentals aims of improving the didactic material and making the laboratory practices more environmentally friendly and sustainable, we start this project in the laboratory subjects of Physical Chemistry 1 and 2. Okay, in the next slides, I'm going to present the proposed methodology of this work. So, to redesign the laboratory practices, we needed to consider the interdependence, a correlation between practical and theoretical subjects. This led us to analyze the key topics in the theoretical courses of physical chemistry. In doing so, we know that the laboratory of Physical Chemistry 1 focuses on thermodynamics, specifically in thermochemistry, chemical equilibrium, and phase equilibrium. Meanwhile, in the laboratory of physical chemistry 2, the main topics include chemical kinetics, surface chemistry, and electrochemistry. With this approach, by incorporating some principles of green chemistry, we developed 8 fundamental stages that form the basis of the methodology implemented. So, first stage. Initially, we utilized a manual titled Applied Physical Chemistry, which was designed by professors of industrial chemistry and chemical technology program in 2008 for the experimental practices. In addition to be outdated, our analysis of this document revealed excess in the amounts and types of reagents being used, including toxic reagents that could be replaced nowadays. Therefore, in this stage of analysis of existing didactic resources, the principles of green chemistry would be fundamental. Second stage. Initially, we utilized, in the second stage, on the basis of the above, we developed the analysis of the quantity of reagents, residues, and the application of chemical instrumentation. For this, during this stage, we analyze first, the amount of reagents and consequently the waste generated was reduced. In this second step, practices that could be benefit from a more updated concepts were redesigned. Now, single-use consumables on the most toxic reagents were replaced with the less pollution alternatives. And finally, more updated and accessible concepts were incorporated for the students. In the third stage, we conducted a comprehensive bibliographic review of articles, protocols, and guides. Moving on the fourth stage, we propose laboratory practices that could be applied at our university, taking into consideration the materials, reagents, and the instrumentation available here. Okay, and fifth stage, the millimetric scale proposal was generated when considering the principles of green chemistry, specifically 1, 5, and 7, waste prevention, safe ensembles and auxiliaries, and the use of renewable feedstock, we identified the following essential advantage offered by the millimetric scale concept. Firstly, it enables the development of experimental practices using minimum amount of reagents without compromising results, utilizing the instrumentation already available in the chemistry faculty. Okay, good. This rationally guides our decision to work a millimeter scale rather than a micro scale, avoiding the need for additional devices such as micropipes or other more specific equipment. This concept was achievable because many of the prepares studying the physical chemistry 1 and 2 laboratory subjects are intensive prepares, including specific heats, conductivities, molar enthalpy, and reaction rate. Okay, sixth stage, the pilot phase was implemented, focusing on putting the repeatability of the proposed result in the practice. And here you can see some pictures of the practices conducted during the pilot phase. Okay, seventh stage, we are currently in the didactic result final design. While it encompasses general aspects such as title, objectives, or theoretical aspects, I would like to emphasize the procedural step. This is crucial because we have placed special emphasis on making practices more comprehensive for students. This improvement became possible because through the addition of more details in the manual about the execution of experimental and inclusion of specifications for the use of equipment. Finally, don't know what is happening. Yeah. Laser laboratory implementation is plain. Yeah. In these next slides, I'm going to show the results of this new methodology. So far, we have achieved very positive results encompassing both of the principles of green chemistry and noticeable improvements in the academic performance of the students. Here are some of them. In thermochemistry, we emphasize the reduction of quantities and the development of design skills among students. They construct their own calorimers using materials such as canned cardboard or cotton. This shifted us from using a few joules calorimers with a waste generation of mainly acid and base solution of 300 milliliters to bespoke calorimers made from recyclable materials, resulting in a reduction in waste, specifically 150 milliliters. Now, to extrapolate more general results, these quantities should be multiplied by 20 physical chemistry laboratory groups per semester. Furthermore, the materials used for constructing the calorimers are reduced by students in subsequent courses. And the picture on the right is a handmade calorimer made by the students. Okay, we proceed with chemical equilibrium. Where in the picture we analyze of equilibrium constants for various acid-base indicators previously generate approximately 5 liters of waste. Now, with adjustments based to solutions concentrations, methodologies, and the quantities to be prepared, we generate only about a liter of waste. Those are organic indicator solutions. Okay. In the context of phase equilibrium, the emphasis was on replacing analytic reagents with readily available substance, as seen in the transition from absolute ethanol to a commercial one. A similar substitution occurred with ethyl ether and thinner. Shifting from a highly volatile reagent to one that can be easily obtained at stores. Now, concerning physical chemistry too, specifically in the realm of electrochemistry, there is a focus on promoting the use of robust equipment. Initially, we configured a set of electrochemical cells, resulting in the generation of 5 liters of waste. Those are potassium ferrocyanide solutions, along with the presence of hazardous solid wastes. This practice underwent a redesign and transitioned to a potentiostat galvanostat, resulting in the generation of only 50 milliliters of waste. Okay, now, Furthermore, evidence in the field of electrochemistry highlights the design of kits of students who construct their own electrochemical cells in the case two experimental practices are replaced. we transition from analyzing the behavior of various electrochemical cells, generating 11 liters of waste solutions with different salts, to designing and operating an electrochemical cell, resulting in only 100 of neutralized acid-base solutions. Similarly, the use of substantial amounts of reagents such as copper sulfide or zinc sulfide is replaced by diluted solution of hydrochloric acid and sodium hydroxide. Additionally, heavy metals like cadmium or silver are substituted with iron and tungsten. In the realm of surface chemistry, there are two principal focuses. First, a significant reduction in weight was achieved from 6 liters of acid solutions and potassium permanganate to less than a liter. Second, the use of oxalic acid and potassium permanganate was entirely eliminated. About chemical kinetics, we transitioned from 5 laboratory practices to 1 practice with different approaches. Waste generation has been minimized from 45 liters to almost 2 liters, including substances such as hydrochloric acid, sodium thiosulfate, sodium hydroxide, among others. Okay, this is a description of the next steps for this research project. Among many other laboratory practices, these represent some of the most relevant. However, in approximately 28 laboratory practices, we mostly manage to implement some principles of green chemistry. Finally, we are planning to evaluate new laboratory practices that within the framework of green chemistry, allow students to consolidate concepts and teachings. In this way, we also seek to influence other courses of the chemistry school. By 2024, we are planning to publish a new laboratory manual, and we are planning to quantify the cost reduction using the new methodology in laboratory practices. These are some of our references, and that's all. Thank you so much.